Okay, guys, so what I'm going to start with is I'm going to show you the notes for 2.9, working with equations of hyperbolas. So just a quick review on the warm-up. You had to figure out which one of these each one stood for. This one is because this is a plus sign, this is an ellipse, and it's equal to 1. This is a plus sign. You would think, well, maybe it could be an ellipse. And so if we divide by 9, the two sides are the same. So this is truly a circle. All right, and in this one, that's a minus sign, so it's a hyperbola. And then this last one is a parabola. But this is not the only way you will see it. You can actually see this if they are in conic form as well. So you need to pay attention to if you have like x squared plus y squared. If our variables in front of these match, then it is a circle. So if we have an a here and a b here, if a equals b, then that is a circle. If a or b equals 0, that is a parabola. Because what would happen is it would get rid of one of your x squared. Parabola. And if a is not equal to b, it is an ellipse. And if either, I'm out of room, either A or B are negative, then it's a hyperbola. That's an arrow. Hyperbola. Okay? Just so you know. That's the shortcut of it. All right, so going on to example 1, you need to write an equation. Okay, so you need to know that the equation of a parabola is either x minus h squared over a squared minus y minus k squared over b squared equals 1, or it's y minus k and x minus h, and they swap. Okay, it all depends on the direction that it's opening. So I have this generic way of writing it, equals 1. Okay, and I can do that over, so something minus something squared minus something squared equals 1. This is part of every single equation. Okay, so since this is opening up and down, that means that this is the transverse axis and these are the vertices. So the transverse axis is following the y, so y comes first. So that means I have y and x. Over here, these are my vertices. So this is my transverse axis. My x comes first. So that's x, that's a y. All right? So just so you can tell, that's how I know how to start it. Then I go down here and I find the center. The center is at 2, negative 2. I fill in 2. And when I fill in a negative here, it turns it into positive. Then I have to say my vertex side gives me the A. This is my vertex side, so that's the A. My non-vertex side is called the conjugate axis, and that gives me the B value. This conjugate axis right here, half of it is the B value, which that tells you what goes underneath. So this A is 2, so 2 squared is 4. This B is 2, so 2 squared, is 4. My phone rang, and I'm going to have to call her back. All right, so I just want to finish this video. All right, so this one's done with 4 and 4 on the bottom. This one, the B is 3, The A is 2, so 2 squared is 4. 3 squared is 9. And haven't even filled in the center yet. I got really excited about that. The center is 0, negative 2. So I would go over here. You can fill in 0, negative 2. If you decide to leave that out, I'm okay with that and just have x squared. Okay? I'm done. All right, so I did the you try along with it. This one, I'm not going to do both of them. I'm just going to do one. I wanted you to see how easy that was. Now, in this one, I did tell the classes that it's kind of moot in the fact that they give you this, but this does make it easier. It is easier because if it's a horizontal orientation, that means I know that wherever the axis is, it's going to be parallel to the x-axis because the x-axis is horizontal. So I'm going to start with x minus y minus something squared equals 1. Okay? That's the setup because it has horizontal. I also know it gave me the center, so I've got plus 2 minus 5. Okay, so if I go in here and I plot my vertices, negative 8, positive 5, almost did negative 5, excuse me, negative 8, positive 5, and 4, 5, somewhere in this ballpark, not to scale. See how it's parallel to my x-axis? Okay, so this is from negative 8 to positive 4. So that distance from 8 to 0 is 8 plus 4 more is 12. This whole thing is 12 units long. So that means if we cut it in half, it's 6 and 6. So that means immediately this 6 gets squared. That's 36. Well, then it says the length of your conjugate axis is 12. Conjugate axis is what's here in red. So if this length is 12 from this end to this end, then that means half of it is 6. Oh, wait a minute. Each side is 6. So that means over here we're going to take 6 and square it 2 and get 36 again. It does not always match. Okay? All right, so there's that problem. I'm not going to do this one for you, except to say, you can check it and see if it's right. It's going to be, it's vertical orientation, so y minus something squared minus x minus something squared equals 1. And your vertices, negative 3, 0. Negative 3, negative 8. I think I've missed every time I've done that one. The vertices are here. It means it opens up in this kind of direction. All right. And I know that whole length is 8. And the length of the conjugate axis cuts through the middle, and it's only 2. That's only 2 between these two ends. All right. So I'm going to let you try it and see if you can get it right. All right? Going on, I'm going to go ahead and do this one as well. All right, so the first one, this one they're not as nice. They did not tell me what the orientation is. So all I know is that I have something squared equals 1. That's the setup. That's all I know. So I'm going to go down here and I'm going to draw 5, 5, roughly here, okay, 5, negative 7, 5, negative 7 down here. It's going to open up in a y direction because it's parallel to my y-axis. So y goes first and then x. Next thing I'm going to do is say, well, where is the middle of this guy? The middle of this guy is somewhere in here. And I know that this center is going to be at 5 comma something because the two x's match. The y's are a difference from positive 5 down to negative 7, so that's a total of 12. So that means 6 in each direction. So the middle has to drop 6 from 5 or come up 6 from 7. That's going to put me at negative 1. So now I can fill those in. So I've got 5, negative 1, okay? The next thing I'm going to do is say the conjugate axis is right here. Wow, it's crazy big. All right, so the conjugate axis is at positive 16, so that's somewhere up here in negative 1. 16, negative 1, and then the other one is down here at negative 6, negative 1. And this one is something what it looks like, okay? So I have gone from negative 6 to positive 16. Well, going up to 0 is going to give me 6 and add 16 more. This whole thing is 22 units long, which that means 11 on this side, 11 on that side. So that 11 and 11 is going to give me 11 squared, which is 121. This 6, square it, it's going to give me 36, and I'm done. Okay? I'm going to leave the other one for you to do. Number 4. This one, the vertices, now this is a little different because of the foci. The vertices are at 1, negative 10, and negative 15. This goes way out on the negative side. Okay, so out 1, negative 10, 1, negative 10, this is a vertex, and negative 15, negative 10, something way out here, negative 15, negative 10, that is a vertex, so that means it's going like that, opening up something like this, okay? So from that, I'm going to know the center of it is located between the 1 and the 15. Well, that's a total of 16 long because it's 15 in the negative, 1 more in the positive. That's a total of 16. So each side is worth 8. So even before I get going, I know that 64 is going to be on the bottom right there. Isn't that funny? I haven't even figured out the rest of it yet. I know it's x minus something squared and y minus something squared because it's opening up in an x direction. It's parallel to my x-axis, all right? So once I have that, I can also find the center. So 8 down from 1 is negative 7, and it's at the y value of negative 10. So that means I can go ahead now and fill in plus 7 plus 10, and I've at least got that filled in. The only thing I have left to do is to figure out what in the world's going on with this foci business. Well, the foci, if you look at the foci, I have negative 7 plus this funny looking thing, and then comma 10. Wait a minute, there's a negative 7, 10. Because I had a square root involved, I can actually see the vertex is sitting there staring at me. Look, there and there. So what's being added? 2 times the square root of 17 and subtracted 2 times the square root of 17. This is the C value. And you're like, what is that C value? The C value is giving you a focus of somewhere over here. So the parabolas are opening up. The foci is inside of each of these hyperbolas, okay? It's inside of each one. So if that's the case, if it's inside like that, then that means this distance is going to be bigger than my original one, and that distance is C. Now, a squared plus b squared equals c squared is all that we need, because I know that this 8 right here is a. Okay? So if 8 is a, then I have 8 squared plus b squared equals 2 times the square root of 17 squared. Now I'm going to point something out. Now you can put that in a calculator and it will give you the answer. But guys, I'm going to write it over here on the side. If I have a times b to the x power, this is equal to a to the x times b to the x. Okay? Why am I telling you that? Because you have 2 times the square root of 17 to the second power. So that means you have 2 to the second and the square root of 17 to the second, but they undo each other, so times 17. If you multiply this out, it will give you 68. This is 64 plus b squared equals 68. B squared is 4. B is plus or minus 2. I'm sorry, you don't need to know what b is because b squared is what goes right here, and you can just write that 4 right there. Okay, we are done with that. I'll leave the other one for you to do. The examples here, I believe this is the one I just did. Oh my goodness, it's different. It's not the same one. I'm going to leave it out because I did make another video on that. Check out my other video on those. Have a good day.